Okay, so in this video we have a block that's starting at rest and it slides down a frictionless track. It leaves the track horizontally and flies through the air and then hits the ground right here. So we have three questions that we're going to solve in this video. A, we're going to solve speed of the block when it leaves the track. B, the horizontal distance the block travels in the air, and then C, the speed of the block when it hits the ground. So first, looking at our diagram, we have a 500-gram block that starts at rest at 3.9 meters. And this height will be indicated by HB, B standing for blue, just to differentiate between the two heights. And then the lowest height of the track right before the block would leave, this height, is 2.8 meters, which we are going to call HP, or height pink. Okay, so to begin, with A, the speed of the block when it leaves the track, we are going to use the law of conservation of energy, which basically states that in an isolated system, the total energy will remain constant. So that basically says that it's neither created nor destroyed, the energy. So what we can do is we can set the energy equal to each other at 2 points in the equation, in the problem. So we can look at the diagram and we can see that we could call this position a point, I guess, and then this would also be a point, and we can set these 2 points equal to each other and they would have the same energy, and that's why we set them equal to each other. So here, the block has potential energy, which is equal to mass times gravity times the height, and then at this point the block has potential energy and kinetic energy, and so we have that point being mass times gravity times HP, this new height, plus half times mass times velocity squared, which equals the kinetic energy at that point. So here we can cancel out all the masses, leaving us with gravity times HB equaling gravity times HP plus half B squared. Next, I cancel out these two g's, but we can't forget to divide it here because there wasn't a g to cancel out in this term. Next, I subtracted HP from both sides, and then you can multiply by 2g, leaving you with 2g times HB minus HP equaling v squared, and finally you can square root both sides to give you your working equation right here. So now we can plug in our numerical values and we solve it to find that the velocity when the block leaves the track is 4.646 meters per second. Okay, next, part B, is the horizontal distance the block travels in the air. So we can use kinematic equations to solve this part of the question. The one we can use is x equals x initial, and the O represents initial, plus v initial times t plus half a t squared. So since we're looking at the x direction, we can cancel out this term because it has acceleration in it, and in the x direction acceleration is 0. So we can completely cancel this out. And XO is also 0 because we're trying to find the final, which would be our actual number. So we're left with x equals v initial times t. Now we already found v initial. V initial was right here. That was part A, so we already have that number. But we don't know t. So one thing we can do, we can kind of stop this question and look at finding t to help us find x. Now for t, we can use the same equation, the same kinematic equation, but it's going to be in a different direction. We'll use the y direction because we know the distance in the y direction. The distance in the y direction is the height, which is 2.8, or HP. So we can use the same equation, and I switched the y to being HP because technically that's what it is. The y distance is the height. And here what we're canceling out is the velocity, because for y direction there's 0 velocity. So we can cancel that out, and again cancel out y initial, and that leaves us with half g, because in this case our acceleration is gravity, half g times t squared. And then we'll solve it to find our working equation down here, which gives us the square root of 2 times hp divided by g equaling t. So we plug in our numbers, and we find that our time for the block to reach the ground is 0.756 seconds. So we can plug this number that we found, back into our original equation. So this is the velocity from this question, then we have our time from this question, plugging them back in, and we multiply them, and we get our horizontal distance that the block travels in the air to be 3.512 meters. Okay. Last question is C. What is the speed of the block when it hits the ground? So we're looking at the speed when it's like right here. So for this question we can again use the law of conservation of energy. So essentially, again, we're going to pick 2 points. That's the way I like to think about it, at least. So I look at the equation, and obviously one of the points is going to be right here, because that's what we're looking for. We're looking for the speed right here, so this has to be a point. Now we have 2 other options. We could use the information here and set its energy of the block at this point to the energy at this point, but I think it would be easier to use this point because we would only be working with potential energy because the block is at rest at this point. So, using that initial starting point, we have the potential energy of the starting point, which is m times g times hb, equaling the kinetic energy as the block is hitting the ground, which is 0.5 m times v squared. So we're going to find our working equation. So we times by 2, and then we square root it to get the square root of 2 times g times hb, plug in our numerical values, and we get the velocity when the block hits the ground to be 8.747 meters per second. So those are our answers to this question. And you can see that throughout the whole question we never actually needed the mass of the block. So that's very convenient. Thanks for watching!